case, when that vertex, when two lines or line segments intersect outside the circle, what happens? Well, there's really three ways that this can happen. When we have two secants intersecting outside the circle, two tangents intersecting outside the circle, or a secant and a tangent intersecting outside the circle, they all have the same relationship. They all are half the difference of the two intersected arcs. So what does that look like? Well, let's take a look at this case first. All these cases are going to be basically the same, so we'll just look at one. And again, I'm going to draw in a chord from B to C, and this creates a triangle. Wow, imagine that. We've used a triangle a lot. They're pretty useful in geometry. And I'm going to also look at angle 2, I'm going to call it, the exterior angle, which we've also used a lot today too. Now, we know that angle 2, the exterior angle, is equal to the sum of the opposite interior angles. So angle 1 plus angle B is equal to angle 2. We also know that since angle 2's vertex is on the circle, it's equal to half of its intercepted arc, half of arc BC. And also, since angle B is an inscribed angle, we know it's half of its intercepted arc, AC. So let's substitute. So, we're trying to figure out this relationship regarding this angle outside, so let's solve our first equation here for angle 1 by simply subtracting an angle B from both sides. Thank you, algebra properties. And now let's substitute a few things in. Replacing angle 2 with 1/2 arc BC, replacing angle B with 1/2 arc AC. We're just about there. We can simplify and see that angle 1, the angle outside the circle, is equal to 1/2 the difference of the intercepted arcs.